section 3.2 continued from yesterday, and this isn't going to take long today. We're going to get through this pretty quickly. We talked about all of this stuff. We got through this page, and I believe right now we are right on page 3. We're only going to do page 3 today. I think we'll save page 4 for another day. But for right now, we're going to talk about the graphs of exponentials and logarithmic functions. So last week we talked about what does a graph of an exponential look like. And the graph of an exponential looks like f of x here. So I have f of x equals 5 to the x power right here, and I graphed it right here. And we talked about, in your 3.1 notes, we talked about asymptotes of that graph and the y-intercept, and we talked about whether or not it was increasing. We talked about the range, etc. So I want you guys to remember that logarithms and exponentials are inverses of each other. So if you have an exponential and you need to undo it, you would use a logarithm. And if you have a logarithm and you need to undo it, you can use exponentials. So because they are inverses of each other, if you recall from, I guess, 2 sections ago, inverses are always reflections of each other over the line y equals x. This is the line y equals x. Do you see how f of x and g of x are kind of like reflected over the line y equals x?
Yeah.
That's what happens when you graph, for instance, here 5 to the x power versus log base 5 of x. Yes?
Is f of x supposed to be touching the x-axis?
It is not supposed to be. It's hard to draw those things so that they're not. But this is not supposed to be touching. What is this thing called right here? Horizontal asymptote. Yeah, so it never touches. This gets closer.
There you go.
Yes.
Right.
Who does he have a hand up? Marcus, did you have your hand up? What was your question?
I was going to say something about asymptotes, but you already said it.
I already said it. Okay. All right. So I just wanted you guys to be aware of the fact that exponentials and logarithms are always reflections of each other over the line y equals x because they are inverses of each other. So I made a note of that over here. Since they are inverses, they are reflections over y equals x. There's a chance to finish
That's a big group.
writing.
Very slow too.
Yes.
All right, so logarithmic functions, f of x equals log base a of x, where the a value is bigger than 0 but not equal to 1, they have some special features. So first of all, the domain. What is the domain of this graph? This is a logarithmic functions always graph to look like this. What is the domain of that function? Yes?
Can I take a guess?
You can take a guess, yes.
Is it from 0 to positive infinity?
Almost. Nope, not negative infinity. Marcus, you were so close. You're almost on fire.
Almost.
1 to negative infinity?
No, because here's 1, and we are taking logarithms of numbers smaller than 1. We're taking the logarithm of that number.
Anything greater than
Anything greater than 0. You can't take the log of 0, but you can take the log of anything bigger than 0. So the domain here is going to be, remember this? You put the parenthesis there.
1.
The parenthesis means it doesn't include 0, but it's anything, you can take the log of anything bigger than 0. So anything from 0 all the way to positive infinity, and then of course you always put a parenthesis with positive infinity, or with any infinity actually. What about the range? Yeah,
Is it from negative infinity to positive?
yes it is. The range is from negative infinity to positive infinity. The reason it is because this line, this graph, heads down infinitely far. It will keep going and going and going and going and going. Therefore, it starts way down here at negative infinity and it heads all the way up. And this thing is curving to the right, but at the same time that it's curving, it is headed up very, very slowly, but it's headed up, and it will continue to get a little bit higher and a little bit higher and a little bit higher. Therefore, the range is everything from negative infinity to positive infinity. So there's no horizontal asymptote? There is no horizontal asymptote, but in this case,
Vertical asymptote.
there is a vertical asymptote, a VA rather than an AJ. But first of all, what about the x-intercept? What is the x-intercept? Positive 1, 0. So when we were talking about exponentials, they did not have an x-intercept. Exponentials had a y-intercept. Remember, exponentials are up here instead. They don't cross the x-axis, they cross the y-axis. So the x-intercept here is 1, 0. Is the graph increasing? Yes, it is increasing. The graph is headed up, and it's increasing from negative infinity all the way to positive infinity. In other words, the range and increasing in this case kind of be the same thing. What about the vertical asymptote? Is there a vertical asymptote? Yeah, there's a vertical asymptote right here. And that vertical asymptote, what do we call that?
Zero.
Is it y equals 0? Is it x equals 0?
Y
It's
equals.
Y equals.
It's actually x, since it crosses, well, like in this case it's a bad example because it's right on top
What a
of the
horrible example. What
Look
a
at this.
horrible.
Anytime you have a vertical line, it's going to cross the x-axis, regardless of where you draw it. And if it crosses the x-axis,
Oh.
you call it x equals something. So in this case, the vertical asymptote is going to be x equals 0. Is the graph continuous?
Yes.
Yes.
Definitely goes on and on and on. So yes, it is continuous. All right.
We're done.
Almost.
Oh man.
I'm going to give you guys a piece of graph paper. Remember last week we graphed some exponentials? Jacob,
He's laughing. It's okay. Calm down.
are you having a hard time with the news that you announced to me earlier?
Yeah.
We'll talk about it, alright? Last week we talked about, we graphed some exponentials. Now what we're going to do is graph some logarithms. I'm going to give you a piece of graph paper here in a minute. And it's going to look like, I just want to make sure that I get this part on video. So it's going to look like this, and you guys are just going to graph some logarithms. Now when you're graphing these things, the first function that you're going to graph is that the first graph that you are going to graph is going to be log base 10 of x. So you can just go to y equals, you can type in log of x. Remember when you use the calculator, everything is assumed to be base
10.
10 unless I tell you otherwise, okay? And then we're going to talk about what happens when you don't have base 10, okay?
Yeah.